So now that we know about the xy plane or the Cartesian plane, we can talk about how to graph an equation. So first off, an equation in two variables. Let's call them x and y. It doesn't have to be x and y, but typically the two variables that we're going to use are x and y. It's a statement in which two expressions, those two expressions will be involving an x and y, are equal. So it's just going to be an equation. We have two different variables and we're going to have two sides. Both of them will be set equal to 0. Solutions to this are going to be of the form x comma y. So we're going to have an equation. It's going to have two sides to it like all equations do. We're going to have two different variables. Any solution is going to be x, y. The graph is plotting all of the x, y. So that's going to be how we're going to graph an equation. So for example, let's look at 2x plus 1 equals y. So here on the side I'm going to have my x-axis and my y-axis. Maybe we'll mark off some check marks here. So let's think. Can you give me any x and y coordinates that will make this statement true? Let's think for a second. If I choose x to be 0, remember my x is always going to go first, it's x comma y. If I choose x to be 0 and y to be 1, then this statement is true. Meaning if I replaced x with a 0, this would be 2 times 0 plus 1, and that would be my y. So the point 0, 1 is going to be a point on my graph. Maybe x is 1. Well, if x is 1, what does y have to be? Well, that would be 3. So I'll put that on my graph here. How about negative 1? I haven't done any negative numbers yet. So if x is negative 1, what does y have to be in order for this to be true? So I'll have negative 2 plus 1 gives me another negative 1. So you can see, I mean, there's lots of these. You can pick any x values you want as long as they make the statement true. So any x and y values that make this statement true are going to be on the graph. And if we kind of connect these, we see the general shape of the graph. Let's do one more. So how about y equals x squared plus 1? So I'm going to have some x values and some y values. And then over here I'm going to plot them so that we can see what the graph looks like. So let's start with maybe x equals 0. If x equals 0, what does y have to be in order for the equation to be true? I think it has to be 1. So we're going to plot that there. Okay, what about 1? If x is 1, what does y have to be? Well, it have to be 2. And what about negative 1? Well, same thing. If I plug in negative 1 here, I'm going to get a 2. Let's do 2 more. How about if x is 2, what does y have to be? I believe a 5. And then if x is negative 2, same thing, 5. So we'll have points up here and here. So what does the general shape of our graph looks like? It looks like it's doing this. But you see, by plotting these points that make the equation true, we can see what the graph looks like. So we have to figure out points that make the equation true and then plot them. One more of these. Is the point 1, 2 on the graph of the equation 2x minus y equals x squared. Remember, a point is on the graph if it's a solution to the equation. So if I plug those two numbers in for x and y, if the equation is true, then it is. If it's not, then it's not. And it's not on the graph. So I have x is 1, y is 2. So let's just plug it in and see if it's true. So is it true that 2 times 1 minus 2 is equal to 1 squared? So everywhere I saw an x, I put a 1. Everywhere I saw a y, I put a 2. Let's see. 2 times 1 is 2, minus 2 is 0. Is that equal to 1? Because 1 squared is 1. The answer there is no. So, no, that point's not going to be on the graph. When you put it into the equation, it wasn't true, so not going to be on the graph.